One of the major problems in deploying an application is it usually works in development but does not work in production. Docker is a tool that can help minimize that problem. So my talk is entitled Managing Docker Containers. I'm Lo Siu Yin, a technology consultant with Beyond Broadcast Limited Liability Partnership. So why Docker? Docker is a good way to deploy a 12-factor app. The 12-factor app is a very good philosophy, methodology. I'll let you read all about it at 12factor.net. But essentially, a 12-factor app helps to minimize divergence between deployment and production. And Docker meets this very well. So what is Docker? Docker is a tool that allows you to package your application into a Docker container. This container can then be run on any Linux host running a recent kernel 3.8 and above, with the exception of Red Hat Enterprise Linux 6.5, which has backported the necessary patches to run Docker. To install Docker, go to docker.com and you'll have comprehensive instructions there on how to install Docker on many kinds of platforms. To get help, just run Docker without any arguments, and you get a list of Docker commands. So here is how we set up and create a Docker container. Right, we're going to use the Docker run command, and we're going to name the container Ger, G-E-R. I like Leo the lion, and Leo the lion goes Ger. This Docker container will run in the background. It's going to be a daemon -d, and I'm going to inject two environment variables, deep with a value blue-green algae and Ger with a value bow. It will run the container and build it from the Ubuntu image, and within that Ubuntu image it will run bash, essentially a endless loop echoing Ger and the environment variables Ger and deep, as well as a date every 3 seconds. Right, so let's run this. It says launching Docker container, and it gives this very long string. I think it's a SHA-1 hash, SHA-1 hash. It's an ID of the container that has launched. Okay. Let's look at the container's log. If we run that, we see it is indeed running. And if I run it again, now that's the last 33 seconds. If I run it again, it's now 39 seconds. Good, it's running. Docker actually captures your application's standard output and standard error into a JSON formatted log on the host. And it's JSON formatted actually because it actually captures timestamps, and I can demonstrate by applying a -t there, and I run it again, and now you have all the timestamps. Good. Yeah. Let's close that. So right now Docker is at version 1.2. It hasn't gained the ability to automatically rotate log files yet. So please set up log rotate to rotate files on your Docker host. Otherwise, these files will grow without bound and take up all the disk space on the partition. Right. I said previously that the container was created from a Docker image. So let's talk about Docker images. What's the difference between a Docker image and a Docker container? Think of an image as a software build. Say we have an SMTP server, and this server is in an image called postfix. So this is the image that can run on any Docker host. That's CentOS or Red Hat or SUSE or Ubuntu host. A Docker container, think of it as a deployment, a configuration bound to a build. Let's say we want an email server running for example.com. So we take this postfix image and bind it to a configuration. In this example, oversimplified, I know, The configuration is just the address example.com. However, it does not become a Docker container until you actually use the docker run command on it. Docker run will actually create the container from the postfix image in the process of running it. So once you've run docker run, you now have example.com's email server running in a Docker container. You can stop the container, then of course the email server will stop. You can kill it. It's a more abrupt version of stop. You can delete the container and you can restart the container. We'll talk about this. Docker provides several commands to help you manage images. So you can download or pull an image from the Docker registry, hub.docker.com. Think of the Docker registry as a GitHub for Docker images. The Docker registry is an open source software, and you can run your own Docker registry if you don't want to use the public registry. So how do you get an image in the first place? You build it. You build it from a Docker file which you write. A Docker file has a simple syntax similar to a bash script, or you can commit a running container or container which you have previously created from the docker run command. Now, after getting this image, creating your image, you can push your image to the Docker registry. But if you have previously pushed an earlier version of your image, only the changes are pushed. So think of pushing as applying a diff to the GitHub repository. Similarly, for deployment, you need to pull down or download a Docker image. And if you've already previously downloaded an earlier version of the image, updating the image involves only downloading the change bits. More information about these Docker commands at docs.docker.com. Right, so let's try to commit a container to an image. Here is a bash script which will commit our running Gur container to an image called Syrian/Gur 2014-0827. Syrian is my login ID on the Docker registry. Gur is the name of the image, and 2014-0827 is a tag which I can use to tag any particular image. Very good. Think of it like a version number. So if I run this bash script now, it says I've now created this new image, and here is my image ID, which starts with C648. Good. Let's run the image which I've just created, and I'm going to call it Gur1. I'm going to name it Gur1. It's also going to run in the background, but now I'm going to change the environment variables, deep purple, and Gur is now bear, so you should actually see purple bear. And I'm going to run this image which I've just created. Running it, it works. So I now have two containers running, Gur and Gur1. Let's close this and go back to our log there we are. So let's look at Gur1. Don't have to look at the timestamps. Run it, and purple bears. Hey, if I look at the Gur container, not Gur1, and I run this, I get blue, green, ugly, and bow. So indeed, I have two containers running now. Good. We now have two Docker containers running, Gur and Gur1. So let's go back to talk about containers. Okay, back to Docker containers. But first, I want to run a real container. This is a container which I created called w.web. It's a web application that provides a flow charting service. So let's run it. And that's the container ID. If you can actually see that I'm running on port 8288. There's also an SSH port running on port 3322 on the host. These are the hosts on these are the ports on the host, and this is the ports which are exposed inside my container. So it's inside the container, outside the container. 8288 is outside, 8188 is inside. But as you saw, Docker container ran. How do you know that those ports are actually indeed exposed? So let's use another command called Docker ps. So let's run Docker ps, which is something like the ps command on Unix. I have actually 3 containers running. Those are the container IDs, just the first few characters. The image which the container was built from. So w.web was the image which I ran. The command within the image that runs. Status, this one is up 50 seconds. Here we are. Ports. So you can see that internally the container exposed 443, port 80, port 22, but externally only port 3322 is exposed for the SSH command. But we're not so interested in SSH. Let's look at the web command. Where are we now? Okay, there we are. The web host is now exposed on port 8288. Well, I use 8288 because I actually use 8188 for my w.host, which is actually running right now. But anyway, we have something running on 8288, and the names of the containers are given here. So let's look at localhost 8288 and reload. Voila, we have my web app running. Let's see, boy, press send and reload. Boy, excellent. Going back to Docker containers. So we now have 3 containers running. I actually have created a container several weeks ago. This is a stopped container. I can run ps -a, and now we should see a Postgres container that's also running. Well, sorry, there's Postgres container that's also available, but its status says it's not running. It's exited 7 days ago. So the important thing here is you have a container ID which you can use to refer to a container, or you can use a human-friendly name, g1 w.web. So you can either use the SHA-1 string, the first few characters of it, or the human-friendly name. I much prefer the human-friendly name. So how do we stop a container? To stop a container, use Docker stop. By default, it has a grace period of 10 seconds before it kills the container, abruptly stops it. Girl wasn't written to be stopped, so I'm going to kill it after 3 seconds. So 1001, 1002, 1003, Girl has been killed. So now we have 2 containers running, Girl1 and w.web. We can kill Girl1. Let's kill Girl1 because Girl has been stopped. So killing Girl1, Girl1 has been killed. So it's actually signal number 9, which is the kill process signal, actually. So we have stopped Girl and Girl1. How do we restart the container? The container hasn't gone away, it's just been stopped. So we can just start Girl. Girl is started. And if we look at PS now, let's look at PS. We should see 2 containers running, Girl and w.web. We don't want the A command here, A option here. There we are. W dot and Girl are both running. I've not restarted Girl1. Well, we can do that as well. We can start Girl1, run, and G1 has now restarted. Notice how fast it is to launch a Docker container. It's almost instant. It's a very, very lightweight virtual machine. Launching Vagrant or VirtualBox would take, say, a minute, 30 seconds. This one takes seconds, at the most 2 seconds. So we have learned how to create containers, how to view their log files, how to start and stop a container. So even after a container has been stopped, it still hangs around. So how do we remove the container? To remove a container, use the docker rm command. Now if I run it now, well, G, remember, is running. If I run this now, it says error response. You cannot remove a running container. Stop the container first, or use -F to force. So I don't want to force it, so let's stop the container first. Now I'll kill the container. So let's kill G1 and G, because I want to remove both. So G1 has been removed. G1 has been killed. Now G will be killed. So we've killed 2 running containers, and now we can proceed to remove them. Remove G. Let's run that again. Removing G remove. G1 is now going to be removed. Successfully removed. These slides are available for download at speakerdeck.com/Siuyan. That's the URL. And thank you for listening.